as you go to do activity 3 in the Magpie lab, we're going to want to understand one new piece to this. And when you go into Magpie 3, you're going to see that the get greeting method is exactly the same. And when you go down to get response, you're going to see something new in here, and that's this method called FindKeyWord. It's right there, and it shows up a whole bunch of times in here. And as you scroll further down, you'll see that the code for FindKeyWord is sitting right here. And that's what we're going to be exploring in this video lesson. So if we go over here and we consider one of the statements we looked at before, you'll recall that we would go right here and we would look for the word no, and we would find no. Right there it is. But it's not actually the word no as in N-O, it's the word K-N-O-W, which means something completely different. So let's take a look at what this method is going to do. It starts off with statement, which we had before, and we're going to have this other string called goal, which in this case is the word no. And we're going to have a start position, and in our case we're going to start it at 0. So our start position is at 0, and we're going to trim any spaces on the front and back. We're going to make everything lowercase. Same thing with goal, so we're only working with lowercase letters. When I see int PSN, I'm going to just take PSN to mean position, and I'm going to start off by finding the index of the goal. So I go in here and I find the index of the goal, and there it is, it's at 8. So the index equals 8. And then it's greater than or equal to 0. I set the string before to be space and after to be space, and I'll explain why that's there later. If my PSN or position is greater than 0, then before equals phrase.substring PSN minus 1 to PSN. So basically I'm looking for the substring from 7 to 8. There's PSN minus 1, there's PSN, and I can see that that is a K. So my before equals K. All right. And then I go up here and I then check to see if PSN plus goal.length is less than phrase.length. Basically, I'm checking to see if it's at the very end. So if it's at the very end, I would never do this. But since it's not at the very end, because if I take PSN plus goal length, so for instance, my PSN right now is at position 8. And if I add the length of the goal, which is 2, 10 is less than the entire statement's length. So since that's the case, then I go and figure out after. And after equals my position, which is 8 plus goal.length to goal.length plus 1. So what I'm interested in now is the substring. So let's say we took our index 8. Actually, we keep calling it PSN, so let me just change that. PSN, so that 8 plus the length 2, and I go from there to 10. Well, that's my after, which is W. So basically, we're looking at the letter that comes before and after my goal. All right, so after I have those, I compare them to A and I compare them to Z, and let's just see what that means to compare. They gave us this nice little program, String Explorer. I commented out all their others because I want to show you something here. When I do system.out.println, I'm going to cast the letter A to an int, and you'll see that there is a number associated with the letter A. And if I run that, I get the number 97. And in fact, if I copy this and put a bunch of letters in a row, oops, I can put in the letter B and the letter C. You'll see that those numbers are all in a row. So let's just take a look at that. There we go, 97, 98, 99. And at the end of that is the letter Z. Remember, we're only working with lowercase, so that makes this all much simpler. So here's a Z. So if I compile that and run that, there we go. There's A, B, C, and you know that this is going to be, the 26 letters at 122. Now, why this is useful is because we're going to see other things, oops, like spaces or question marks or commas. So, for instance, if I find the number associated with a space, or the number associated with a comma, or the number associated with a period, or the number associated with a question mark. Let's run that. You will notice, here we go, that those other numbers are not between 97 and 122. So remember, this is A, B, C, this is Z. The numbers 97 through 122 are all letters. These other numbers are not between those, which means they are not letters. And they're probably punctuation, but certainly not letters, which means we've got a word that's not between two other letters, which means it's its own word. All right, so let's go back to this. And we had our before was K, our after was W, and we were right here where we were comparing. All right, so we're comparing before, remember our before, which equals K, and we're checking, does before compared to A, is it less than 0? If it's less than 0, that means K comes before A, which it doesn't. And then we're checking to see, okay, is K come after Z, which it doesn't. So this first statement is going to be false, because it's not less than A and it's not greater than Z. In other words, the letter K comes between A and Z. Then we do the same thing here for W, and we check, all right, is it between A and Z? Actually, is it not between A and Z? Because this is checking to see if it's on the outside. So that's also false. And since those are both false, I don't return PSN. Okay, so notice false, false. I don't go here, and I go down here to PSN equals phrase.index, and now I look for the next occurrence. So I take PS, so I didn't find it. That's what we just found out. This no wasn't just the word NO, there are letters on either side, and so now I go to 9, and I say, okay, when's the next time I find it after 9? So I start looking at 9 right here, and I look through, oh, there is no no. Okay, so now I get a -1. Now PSN equals -1, and now it's no longer greater than 0, and so I break out of this while loop, this whole pink part, and I return -1. And since I return -1, I go to the next thing, and you'll recall in the code, the next thing was to look for brother. So if we look for brother, we go through this whole thing again. Now this time my position is 15. And when it looks for before, the thing that comes before is a space. Yay. The thing that comes after is a question mark. And neither of those are between A and Z. So when I get down to this portion right here, it asks us, let's go through here, does it, when it compare, is it less than 0? And you'll remember when I ran the terminal window, these all were things less than 97. And so what would happen is we would have a true here. And so we wouldn't even do this one because we'd short circuit it. So that's true. And then we'd have an and statement. And the next thing we'd look at was that question mark. And this is also true. And so we would return PSN, which in this case was 15. We found the word brother, and then we're going to have a response that has to do with family. All right, the only other example is to look at, oh wait, one more thing. What if there had been no question mark there? And it tried to find an after. That would be a problem. And it has a fix for that. I'm going to get rid of some of my markings here. So if I had nothing there, I found brother at 15, and remember brother has, let's see, 1, 2, 3, 4, 5, 6, 7 letters there. So we would have had 15 plus 7 takes us to 22, which is beyond what I have. It's actually the length. So let's take a look at where that happens. Right here, my position was 15. I add my goal length, which is now 22, and I ask, is it less than phrase length? Well, the phrase length was 22. I never do this. So then what is after when I come down here? Well, after was set to a space. So if I didn't have anything after it, I already assigned that after to a space. So all's well. Same thing if it was the first word. Before is a space, and I would never do this portion. All right, lastly, I just want you to understand that there's a whole loop going on here. We could find it a whole bunch of times. So notice right here, we have a loop, a while loop, and we keep doing this as long as our PSN is greater than or equal to 0. And if we keep finding it, we do it again. And we only get here if we never did this. If we never did that. Okay, so when we have a return statement in a method, we return and we're done with the method. We don't do any more lines. Now, if we go through this while loop and we break out of it, so at some point, let's say we hit -1, then we're going to hit this last line and return -1. So in our last example, our goal is day. In this case, we start off first with a PSN of 6. We see that what came before was 5, and what came after was a space. Oops, sorry, before is not 5. Before is R. Sorry about that. So before is R, after is a space. And so we don't have a space on each side, so we do it again. We start looking from 7, and the next time we see day is here. So now PSN is 15. And what came before was an O, and what came after was an apostrophe. And that doesn't work because O is between A and Z. So then we start looking from 16, and we find day again over here in 21. So now this is 21. What came before was a space. What came after was a space. Hey, we found it. And so return the number 21. And returning the number 21 means we'll have a response related to the word day.